little more complicated. And it's on the interval -2 to 2. Now, wait a second. Yeah. Okay. So what you should note at first is they did not give you a closed interval this time. All right? They did not give you a closed interval. They give you an open interval.
So it can't be. It can't be
2 or -2.
That's right. You're not going to be plugging -2 and 2.
So can you do -1, 1, and 0?
Why -1 and 1?
Because it's the next one down, right? In between.
Well, I guarantee it goes to -1.5.
Okay.
No, the function doesn't exist. We're looking for absolute extreme value. Looking for the largest value the function takes on.
Yeah, I mean, like, it might get close, like, some -1.99. You see what I mean? So, like, it would get so close to the point where you would be closer to -2 than the other number. That's where.
Right, but if you run the limit on this as you go to -2, right? Then it's going to tell you what this is approaching as you get closer to -2. But the function doesn't actually exist there.
Yeah, you can write something like inequality at that point.
Inequality?
Yeah,
We want the exact. We want the maximum value. The maximum value cannot occur at -2. Not possible because the function is not there. There's no maximum value where the function isn't. It's like the other day. There's no derivative where the function isn't. Right? There's no maximum value where the function is not. So -2 and 2 are not going to come into play in this problem like they did in the other ones. You're not going to check the endpoints. It's not possible. Okay? So we should find the critical values. Find critical values of f. So you take the first derivative, f prime of x. So now you have a quotient rule. Unless you want to change it to a product rule, you can move this up and change it to a -1/2 power. It's your choice whether you want product or quotient. Quotient it is. So we need the bottom times the derivative of the top. So that's times 1. Plus the top, sorry, minus the top. I don't even quotient one. Minus the top times the derivative of the bottom. Oh, shoot.
Yeah, there's a tuner.
I'm just going to write it. 4 minus x squared. We'll take care of it in the next step. And now I need to square the root of 4 minus x squared. So that just gives us 4 minus x squared, right? The square of the square root is the thing inside. That's what we have right now. We need to take this derivative here to complete the quotient rule. So the derivative root of 4 minus x squared d dx is.
Isn't it
Rosales, what are you saying? 1/2? It's a half, right?
It's a
Yeah,
half.
1/2 times what's in the parentheses.
Okay. 1.
It's the -1/2?
No.
No, it's 1/2 what's in the parentheses.
It starts out at 1. It starts out as 1 half.
Negative 1/2.
Yeah, but when you bring it down, wouldn't that make it -1/2?
Correct. So now we'll bring it down.
Yeah. I was just saying the
He's
first
telling me the whole thing. Yeah.
The wrong part.
He's telling me the first part. You're telling me the second part.
Yeah.
Okay. So we got it. There it is.
times what's in
Times
the derivative of
2x,
what's in the parentheses.
-2x.
Times -2x. Great. You guys know chain rule now. Fantastic. All right. So that's what goes to here. It goes there. Hey, here's where you have to be a little more careful. Please be careful. So f prime of x is. I'm going to write this in terms of its fractional power, 4 minus x squared to the 1/2, and then minus x. All right, let's see what we have here, though. The -2 and the 2 cancel, give us a negative. And there's an x here, and there's an x here. And there's another negative here, right? So we're going to have positive x squared, 4 minus x squared to the -1/2. Over the 4 minus x squared down there. Is that right?
Why'd you get rid of the negative?
There's a negative there, and there's a negative on the derivative. That makes positive. There's a 2 here, there's a half here. It goes away. X, x, x squared. Okay?
Wait, I'm confused as to where the x. Oh, x.
2's cancel. We still got a negative, but there's a negative here, so positive. X and this x here, make the x squared. All I have left now is 4 minus x squared, the -1/2. Put it right there. All right. What you saying, Lou? Still is, right? Which makes sense. The original function does not exist at -2 and 2. So therefore, the derivative, there's no slope there. There's no function there, so no slope there. It doesn't exist at -2 and 2 either. You can see that from this expression down here. So in terms of critical points, right? In this case, I don't care where the derivative doesn't exist, because the original function doesn't exist there either. You with me? If the original function does not exist at a certain location, then I don't care that its derivative also doesn't exist there. It's not going to be anything of significance, right? It can't be a max or min. There's no function there in the first place, right? So when we talk about critical values, it's true that it's where it makes the derivative undefined, but I don't care about it unless it makes the original function defined, right? It has to be defined for the original function to be of any significance to us. That's the issue. Oh, you guys are remembering this. I know. I can tell right now.
I'm listening.
I know you're listening. You're not going to remember.
Can you figure
Say it
it
again.
out?
No, but it makes sense.
What's a critical value, Carter? No, Lee. What's a critical? Your answer.
Okay.
Lee, what's a critical value?
F prime x equals 0 or undefined.
Any x that makes the derivative 0 or undefined. That's a critical value. Okay? But I don't care about the x that makes the derivative undefined if it also makes the original function undefined. Because the original function doesn't exist there, then the derivative at that location doesn't exist there either. It's not telling me anything. It's only when it's defined for the original function and it makes the derivative undefined. Oh, maybe something happening now. Could be a max or a min, right? So in this case, even though 2 and -2 make the bottom equal to 0, which means derivative is undefined at 2 and -2, since the original function also is undefined at 2 and -2, the 2 and -2 coming out of this tell me nothing. So I don't care about them. All right?
So can we just pick another number?
No, there's no
Yeah,
other
we'll
numbers
just plug
gonna
random
make it
numbers
work.
in. We'll just plug.
No other numbers are gonna make it.
Let's put in 65.
Oh.
82. What do you want, Cornejo?
Like,
I thought you were doing the same thing as the other
Well,
one.
now, remember, in the other one, we didn't pick random numbers.
No.
We picked the ones that made it 0.
Okay.
So we'll probably find that one.
So how would you answer that? You
Okay.
would just say that.
Well, we're not done yet. We're just trying to find critical values.
Okay.
All right? I just want to make sure of note here that the 2 and -2
Oh, 'cause
are
that
not
was
useful to us.
Part A.
Part A is find all the critical values. We haven't even done part A yet. That's right.
Okay.
We need to simplify this and set equals 0. Yeah.
So we're told where it doesn't exist at -2. Was it give us a point where it doesn't exist as close as it can get to -2?
No, there is no point that's closest to
Wait,
-2.
I think that's why like
Say.
the problem.
Right. There's no in the real number. Okay.
Because like then you can't take the true absolute
No,
number.
you get to it.
You're not
Correct.
saying-
You can't get there.
That's what I brought up.
Instead of
Like, it's
equals
like,
0, no.
couldn't you like use it as a bait? Not because it might not.
To find the
It's
critical
not because
value.
that function isn't
Oh, okay.
existing, but it's
Right
so
before it
close.
does, you say.
Yeah, it's so close that you could write it as an inequality, where you can state that even though it doesn't equal it, that's the best guess you can do.
But the problem is there's no number right before -2.
Like, that's what I mean. So there's a limit to it. So even though it doesn't reach it, it's every single number that's before -2. So
No, I didn't even
like
notice that.
1.9.
But which one's the? We're trying to look for the biggest one. Which one's going to yield the